Okay, we're continuing Chapter 2, Polynomial Functions, with Section 3, Part 1, Graphing Polynomial Equations. The objective of Section 3 is to graph a polynomial function and to determine an equation for a polynomial graph. But again, the focus of Part 1 is to graph polynomial equations. Okay, so what do x cubed graphs look like? If we have a function similar to this one, ax cubed plus bx squared plus cx plus d, when a is greater than 0, so this value here, let's say we have something like y equals 5x cubed plus 9x squared plus x plus 11. So anything similar to this, as long as the a value is greater than 0, it will look like this. And behaviors on this side will be decreasing, and over here will be increasing. In between here, we don't know exactly what the curves will look like, but what we do know is from here, the 3, if we minus 1, so that means 2, our line is going to change direction twice. So what that means is if we're going up here, it will change once and twice. So again, if you're following the line there, it changes direction once and twice. That's what that value there can tell us. Okay? Okay, and something to notice is that as x increases, what happens to y? Y also increases. And as x decreases, y decreases. Okay? Next, we have the case where x is less than 0, so negative numbers. So if we had something like y is equal to negative 3x cubed plus 2x squared minus x plus 4. It's actually just gonna flip, so the end behaviors will be opposite. So it'll increase here and decrease here. And again, 2 turns, so if it's going down, it's 1 turn, 2 turns. Okay, so if you look back here, it's just the very opposite, and you could see it as like a sideways S. Okay, and anything next, we have the x to the 4th, or the quartic. Actually, we're going to go back because I wanted to reference what happens here. So as x increases, y now decreases. And as x decreases, y increases. Okay, so let's go ahead and look at the graph of x to the 4th. So again, if we have something like this as a polynomial function and a is greater than 0, so this would give us a graph like w. So something like, oh, let me try that again. Something like this. So the end behaviors will be going up, and if we look again at the turns, minus 1 from there is 3. So if we're starting going this direction, that's 1 turn, 2 turn, 3 turns. Okay, so that still follows true. Next, so this one is just if a is less than 0, so a negative number, that just flips or is the opposite, so it will be shaped like an M. Okay, so that's the rule for quartic polynomials. Next, we have example 1. Sketch a graph of the following polynomial, f of x equal to x plus 1 times x minus 1, x minus 2. So this is already in factored form, so all we have to do is find the zeros. And I know actually that this is going to be a cubic polynomial because we have 3 roots here. So let's see. If we set each of these equal to 0, we'd get that this one is x is equal to negative 1, x is equal to a positive 1, and x is equal to 2. So we can mark those here. Negative 1, 1, and 2. So the way that we're going to graph this is by doing a sign test. So what that means is for each of these sections between our points or x-intercepts that we found, we're going to test a value. So from here to here, about here to here, we're going to pick a value and we'll test it into our polynomial to see if we get positive or negative values. So between here and negative 1, we could try negative 2. So if we test negative 2 for x, we'd get negative 2 plus 1 would be a negative value. Negative 2 minus 1 would also be a negative value. And negative 2 minus 2, again, negative. And so if we multiply these, negative times a negative is positive, times a negative will still give us a negative. And the reason I'm multiplying these is because in the original problem, they're multiplied. So if we test a value between negative 1 and 1, an easy value would be 0. So if we test 0, by plugging it in for x, 0 plus 1 would be a positive value, 0 minus 1, negative value, and 0 minus 2, again, negative. So positive times negative is a negative, and negative times negative is a positive. Okay, so between 1 and 2, we can test 1.5. Testing that, 1.5 plus 1 is a positive value. 1.5 minus 1 is what? Positive value. And 1.5 minus 2 is negative. Positive times a positive is positive, times a negative is a negative. Last one we need to check is between 2 and anything to the right. So let's just go ahead and do 3. So 3 plus 1, 3 plus 1 will be a positive. 3 minus 1 is a positive. And 3 minus 2 is a positive. So multiplying all positives, we'll get a positive. Now what this tells us here is, let's see, for the section where we tested negative 2 was a negative. Where we tested the 2 was, oh, I made a mistake here. So actually this was supposed to be 0. So let's check that. May have made a mistake there. So if we had plugged in 0, this would have been a positive. 0 minus 1 would be negative. 0 minus 2, negative. So that would have given us positive times negative is a negative, times a negative would be a positive. So between this region, we would have positive. 1.5 would be negative. And 3, we have a positive. So now to draw our line for our graph, so over here, this is a minus, so we'll have that decreasing. Now between here and here, we have a plus. So this is going to be looped up. Between these 2 points, we have a minus, so that's going to loop down. And for the rest of this section, it's a plus, so we're going to have that increasing. So as you can see, this is a graph of a cubic polynomial, and I knew it was going to be because of the way it was factored, and you can see that it gives us 3 different roots. So that's how I knew that this was going to come out to be a cubic polynomial. So I'm actually going to skip this one. We can cover this one in class, but as you can see, it's factored into where it would have 3 roots, so it is going to be a cubic graph. So we're going to go ahead and jump to this one, which we have 1, 2, 3, 4 factors. So that's going to mean this will be a quartic polynomial graph. And let's see, so example 3, sketch a graph of the following polynomial. F of x is equal to x plus 3 times x plus 1 times x minus 1 times x minus 4. Okay, so our zeros here will be negative 3, negative 1, 1, and 4. So we'll go ahead and mark those on our graph. Negative 3, negative 1, 1, and 4. Okay, so as always, we'll do our sign test. We'll have to pick values between these. So between here, we could pick negative 4. You could pick any of these values to the left within this region. I just think negative 4 will be easiest, so I just do the closest that I can. Between negative 3 and negative 1, a nice even number, negative 2. Between negative 1 and 1, easy one is always 0 if possible. Between 1 and 4, we can go ahead and do 2. And then between 4 and anything to the right, we can go ahead and do 5. We'll test all of these values. So negative 4, plugging that into this function for x, we'll get negative 4 plus 3 is negative value. Negative 4 plus 1 is negative. Negative 4 minus 1, negative. Negative 4 minus 4 is negative. Okay, so if we multiply all of these, negative times negative is a positive times a negative. Negative. Negative times negative is a positive. So the next value we need to check is the negative 2. Negative 2 plus 3 is going to give us a positive value. Negative 2 plus 1, negative. Negative 2 minus 1, negative. Negative 2 minus 4, negative. Okay, so positive times negative. Negative times negative is a positive, times negative is a negative. So then we'll try test 0. 0 is always easy. 0 plus 3 is positive. 0 plus 1 is positive. 0 minus 1 is negative. And 0 minus 4 is negative. Positive times positive is a positive. Times a negative is a negative. Negative times negative is a positive. let's see, then we have 2